Okay, this is me going over the Chapter 5 Probability and Statistics Study Guide. I'll also post the completed study guide so that way you can go back and look at the answers. All right, so the first question, would a z-score of 2.76 be above or below the mean? We would say above, and that's just simply because 2.76 is positive. So a positive z-score is above the mean, so 2.76 is positive. Would you imagine the area under the curve to the left of the z-score to be greater or less than 50%? And we would say greater than 50. And you shouldn't need to use the table for this question. So if you just think about it, if this is your normal curve, 2.76 is way out here. And if I shade this area, that's more than half of the curve. And then is a z-score unusual? We would say it is unusual. And that's just simply because of it's greater than 2. So more than 2 standard deviations is unusual. So more than 2 standard deviations. So a z-score more than 2 or less than negative 2 is going to be unusual. All right, number 2. What is the area under the standard normal curve? This is just looking up areas. So if you look up negative 0.27, you would do 1 minus 0.3936, which is 0.6064. To the left of, zoom in just a little bit here, to the left of z equals 0.52. That's just looking it up, which is 0.6985. To the right of 1.15, so 1 minus 0.8749 is the area you'd look up. That's 0.1251. And then between two z-scores, so you look them both up and you subtract the areas. And that's the answer for those. So you just have to know when to look up, when to subtract from 1. Remember, if it's to the right, you subtract the area from 1. All right, the next problem or set of problems is about these green turtles who have a mean of 2,200. So the mean for all of these problems is 2,200, and the standard deviation is 625. So we're going to be using that for all of these problems. So we're assuming a normal distribution, so we can look up we can use our blue table or our normal distribution for this. Find the probability that a randomly selected green turtle migrates distances. So the first one is less than 1900. So the probability that x is less than 1900. So we need to find the z-score first. So I'll do the z-score on the side here. So that's 1900 minus 2200 over 625. So x minus mu over the standard deviation. That'll give us negative 0.48. And we only need a z-score to 2 decimal places because that's all the table is accurate. Your answer is 0.3156. Now I'm not going to put these in complete sentences, but on the test you should be familiar with how to do that. So you would write something like 31.56% of green turtles would have a migration distance less than 1,900 kilometers. Okay, between two values, so between 2,000 and 2,500. So this requires using two z-scores, so the z-score for 2,000 and 2,500. So the z-score for 2,000 is negative 0.32. The z-score for 2,500 is 0.48. So the z-score is the probability that z is between negative 0.32, 0.48. So when you look those both up, because it's an in-between, you subtract them. So 0.6844 minus 0.3745. So the answer is 0.3099. So that's your answer for that one. It's a little crowded. We'll do this next one in a different color so you can see it better. probability that x is greater than 2,450. Once again, we find the z-score. 2,450 minus 2,200 over 625. 0.4. So probability z is greater than 0.4. 1 minus 0.69554. So this is a greater than. So remember, when I look up 0.4, this is what the number you should look up, 0.6554. 1 minus that, though, is what we have to do because it is a greater than. So that's 0.3446. Okay, what is the smallest distance in the upper quartile? So this is when we start going in reverse. So for these problems, I find drawing a small picture is useful. Okay, so the upper quartile, I always get this question. Remember, there's 3 quartiles. There's the first, second, and third. So the upper quartile is the third quartile. So that means that the area to the left is going to be 75% or 0.7500. So using the table backwards, the z-score that goes with 0.7500 is going to be 0.67. So if you look at your table in the body of the chart, you're looking for 0.7500. The closest one is going to be 0.67. So this is where we want to find a value. So x equals mu plus z sigma. Once again, my mean is 2,200. My z-score is 0.67. And 625 is the standard deviation. So that's 2,618.75 kilometers. What is the longest swimming distance in the shortest 10%? Go back to red here. So once again, if you draw a nice curve, shortest 10%. So that means 10% is to the left. So that's 0.1000. So you want to find the z-score that goes with 0.1000. It turns out that's negative 1.28. So again, you're using the table backwards here. You're looking for the area that's closest to 0.1000. So x equals mu plus z sigma, 2,200 minus 1.28, 625, 1,400. Right, and that's the front page. For the back page, if a sample of 12 turtles is taken, what is the probability the average of all 12 will swim more than 3,093.75 kilometers? So we want to find the probability that the mean, so notice how this is about a sample and the probability that the average or the mean, so that is a different question than an individual turtle swimming more than this amount. So the z-score is going to be the mean, 3,093.75, that we want to find the z-score for, minus, we're still going to subtract 2,200 because the mean of the sample means is equal to the mean, but we're going to divide by 625 divided by the square root of 12. And that's because the mean of the sample means is equal to sigma over the square root of n. So that's what I'm doing here. 625 my standard deviation, but now I'm dividing by square root of 12 because I selected 12 turtles. So when you get the z-score, you should get 4.95. So this is the probability that z is greater than 4.95. And this is an interesting one because if you look at 4.95, you try to find that on your chart, you didn't do anything wrong. 4.95 is way out here. So this is a z-score of 0, 1, 2, 3, 4, 5. 4.95 is out here. So this area is so small, and you want something greater than that, it's about 0 because it's off the chart. So anytime you get a z-score off the chart, which doesn't happen too often, but this is just an example of when that happens, you just have to think of what direction you're going. In this case, we're going greater than a very high z-score. Because that's about 5 standard deviations away from the mean. It's almost impossible that that happens, or it's very, very rare occurrence. Interpret the probability from part F in a complete sentence. So about, I'm saying about because it's not exactly 0, it's just about 0. So about 0% of means of 12 migrating distances of green turtles is greater than 3,093.75 kilometers. About 0% of means of 12 migrating green distances of green turtles is greater than 3,093.75 kilometers. That sounds good. Remember when you write this sentence, you have the percentage. You talk about what you're actually talking about. So we're talking about the migrating distances of green turtles specifically, and it's greater than this amount. But don't forget to mention that you're talking about the mean when it is about the mean. So we're talking about the mean and specifically of 12. So that's important. People forget about that you're interpreting something about the mean. So if you're interpreting something about the mean, mention the mean. If it's an individual, mention that it's just 0% of migrating distances. You don't have to mention that it's the mean. So make sure read the question again before you write the sentence. Okay, question 4 then, last one. Business analyst claims the mean annual salary. So once again, so mean annual salary is 29,200 and the standard deviation is 1,500. So what is the probability that the mean annual salary is less than 29,000? Oh, and don't forget that the sample size is 45. I forgot to read that part. So the random sample size of 45. Okay, so we want the probability that the mean is less than 29,000. So the z-score is 29,000. Actually, I'm going to run out of room if I write it there. 29,000 minus the mean divided by 1,500 over the square root of 45. So again, this is talking about the mean, so we have to divide by that square root of 45. You get negative 0.89. When you look up negative 0.89, you get, hold on. You get 0.1867, so that's from your table. So that's the probability. Why can we use a normal distribution to find the probability in part A, even though salaries chauffeur salaries may not be normally distributed? So this is a key part here. Why can you do this? Like, why can I assume a normal distribution? And I've taught you, and if you go back to the green turtle problem, if you go all the way up here, it says the distances are normally distributed. So we can use the table, but there's nothing that says I can do that here. Well, my sample size is 45, which is much larger than 30. So basically, n is greater than or equal to 30 is all we have to write. If your sample size is greater than or equal to 30, we learned that the central limit theorem says we have data that's approximately normal. So that's why we can use that. Okay, similar question, except it's greater than or more than 31,000. So your z-score is going to be 31,000 minus 29,200 over 1,500 divided by the square root of 45. And that's 8.05. So this is a very similar thing as the last one. If I try to draw this curve, 8.05 is not on your chart. Z-score is 8 standard deviations all the way over here. So 8 standard deviations away. Greater than that, it's not. It's about 0. So that's another one that's about 0. Assume the salaries are normally distributed. So now we can assume the salaries are normally distributed. What is the probability a randomly selected chauffeur salary is more than 31,000? So similar question as the part C, but now it's just a salary, one salary. So z-score is 31,000 minus 29,200, but now we're just dividing by 1,500. We don't have to worry about the mean because it's just one salary. So this z-score is 1.2. So this one's not extreme at all. We can look that one up. If you look up 1.2, it's 0.8849, but it's more than, so we have to do 1 minus that. So that's 0.1151. Why are the probabilities in parts C and D so different? Well, basically it comes down to sigma sum x bar is much smaller than sigma. So even though the question is the same, this one is about the mean and this one is when you only have an individual. So that's why they're so different, because you're dividing by the square root of 45 in part C, which changes the standard deviation. And the last question, what about the middle 70%? So we need to find two scores here. We need to find what marks the middle 70%. Well, to get the middle 70%, you need to think, what's on either side? Well, if you have 70% in the middle, that means you have 15% on either side. So if I want to look up the z-score, I want to find the closest to 0.1500. And if you look that up, it's negative 1.04. This z-score here, you can look up, well, that's not good. One second, we're going to let that restart. Okay,